Hello everyone, I'm Frank and welcome to today's hard other type puzzle. So this is not a Sudoku, it's not a Japanese sums, it's some new type of puzzle. I'm not sure exactly what it is, but it's called Candles Reconstruction by KNI. And here are the rules. We need to place candles into some empty cells. A candle has a height of 4 minus the amount of neighbors also containing candles. That is, no candle may have all 4 neighbors filled, as then it would have height 0. So, for example, you could place a candle here of 3, and that means one of its neighbors must have a candle in it. Right? Because if you place a candle with height 3, the candle has to have a height of 4 minus the amount of neighbors, which means cells that share an edge with it, also containing candles. So then this would be 1, which would mean that these neighbors would have to have 3 of the cells that it shares an edge with would also have to have candles. Oh, interesting. That's interesting how that sort of progresses. Clues outside the grid give the sums of heights of connected candles in order, where empty cells separate groups. A question mark can be any non-zero value. So this is this is sort of the Japanese sum part of this puzzle, where basically you have consecutive digits or consecutive candles, consecutive, how do you say it? Consecutive cells with candles that add up to the number, which is the sum of the heights of the connected candles. Okay, so we have connected candles, which are basically candles which does not have an empty cell in between. And so the connected candles must sum up to the heights of the candles must sum to the numbers that are outside. So therefore you have to have a connected sum here of 3, and then you have another connected candles which add up to 3. Then you have another set of connected candles which add up to 3, and then a fourth cell of candles which would add up to 3. And a question mark can be any non-zero value. So it has to have a candle, but we don't know how many. It could be whatever amount as possible. So this is kind of like combination Japanese sums with some new candle technology. Rule set, I guess I should say. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, 3. We have a guaranteed 3 spaces in between here. How many rows and columns do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 3 spaces in between. We know for like the 15 cage, or the 15 candles in a row. So any candles in a row that are made up of multiple candles, you can never have a 4 in that set. So this is going to be a set of 5 candles at least. Because every one of those candles is necessarily going to have a neighbor with a candle, right? Actually, it can't even be that. The ones inside have to be 2 at most, right? because everyone inside is going to have at least 2 neighbors with candles. So then this has to be 3s potentially at the ends. So anything that's larger than 4 must have at most a 3 at the end and 2s in the middle. So for the 15, that's interesting because we're going to have 3 on the ends at most, which means 3 and 3, so that's 6, which means 9 at least candles in the middle, which is at least 5 cells. So this has to be at least 7 cells long to add up to 15, right? We have to have 3 on the outsides. We could have 2s and 1s on the insides. 4 2s and 1 1 is possible. Okay, but it has to be 7 in length. So that's 7, and then up to this being 7 here. So these are guaranteed to have candles in them. This then has to be 2 at most. So this is 1 or 2. One of these at least is unfilled. To have 8, okay, to have 9, it has to have 4 cells. 3 and 3 on the outside, 1 and 2 on the inside. We have to have 7 somewhere in this row. Well, we know this is part of 1. And the 7 cannot be 4 and 3 here, right? Because 4 would not have a neighbor. So this must be part of the 7. Which means it's orthogonally connecting to one of these cells here. So this has to be 1 here, definitely. And it cannot, okay, so if it were to be connected here and not have a candle here, remember, all 4 of its neighbors cannot be filled with candles. So therefore, if we try to have this be the one that has a candle and this doesn't, because these 2 already have a candle, this would have to be 1, and this would have to have 2 candles that it has on edge. So this is 2 at most. Therefore, this would be 3, but that's too small. So this cannot have the candle being on this side or the empty spot being on this side. That means the empty spot must be here, which means this must be connected. And again, it must connect that way. And it has to connect at least to here. So this is empty. This is empty. This has to be at least 3 because this is 2 at most. So this is 1 or 2. This cannot be 1, 2, and 3 adding up to 7. So we need to have another candle there. So this is 1 or 2 at most. And this is guaranteed to have that amount. We have space for space blank. So this could be, we don't know. It could be 1, 2, or 3 here. So this is 1 here. This can never be 4 by itself. So it has to share an edge with something else here. So this is 1 or 2. Because it cannot be 4, it's basically by itself, and therefore it has to add up to 4 as a set. So this is 1 or 2. It cannot be then... okay, so you can't have... If we try to make this the end here, that's not going to work. Sorry, this is the end and this is no candle. That's not going to work because then this would be 2 at most. We'd have 2, 1, 2, 2, 2, 2 at most, which adds up to 11. 11 plus 3 adds up to 14 only. So this cannot be blue. This is green. So this has to be sharing an edge with one of these two and then sharing an edge with one of these two. So, sharing an edge with both of these and then sharing an edge with one of these two to add up to 4. So this cannot be 2, it's 1. So that's 1 and 1. So we have 2 here, 2, 4, 6, 8, that's fine. If we have green here, that would mean this is 2 at most, so we'd have to have another digit here. This could be 3. So again, 1, 2, 3 here, 1 through 3 there. This can't... Can this be 3 anymore? I think the answer is no, right? So you'd have 4 in between, or 5 in between, but that's 1, 2, 2, 2, 2 at most, which is 8. 8 plus 3 and 3 only adds up to 14. So this has to continue on this way, so this cannot be 3. It's 1 or 2. This can never be 3 here. So this is 1 or 2. Interesting. So say this was 2 here. If this is 2, that means it must share an edge with these 3 cells. Sorry, it must have candles in 2 of the 2 cells here. But it's not going to have a candle here as one of the 2 cells, so it must have a candle here. So even if this is 2, that means you have to have a candle here. Because you can't have a candle here if this is 2. And if this is 1, that means this adds up to 6 at most. Which means this must have a candle. So either way, this is having a candle. This then is 5. We have to have a boundary here. We have to have a 4 there, and then a boundary here, and then a 4 here. Or not boundary, a no candle there to satisfy this Japanese sum thing. So this is 4. And this could be 1, 2, or 3 here. This is definitely 4, so there is no candle that shares an edge with it. Hmm. This we don't know. This could be 3, in which case then all of these don't have candles in it. Here, the 5 has to be 2 in size. The 9... At least 2 in size, I should say. Hmm. 4 could be here. And then you could have 4 there. So this could be 4 and 4. Unlikely, but it's possible, right? Um, mm, 9 is interesting. So 9 can have 3 on 3 in the outside. And then you have 2, 2. Or 2, 1 on the inside. Or 3 and 2 on the outside. So it could be like that. That is possible. Hmm. 6 has to have, could be 3 and 3. That works fine. Hmm. $15. Hmm. 6 could be 3 and 3. Five could be 3 and 2. That works perfectly fine. So in column 5, we have 4 spaces to work with. We are guaranteed 3 empty spaces in between the sets of 3s, which could be 3, 3, 3, 3. Um. Mm, this cannot. Well, if this is 3, this would have to be 1, 1, and 1. So how does that work if this is 3? That forces a candle, no candles here. These would have to all be 1, which means how would that work? So this would have to be 1 and 1 here. And that doesn't work. So say we had a 1 here. That's saying that the 3 of its neighbors have candles. So then these would all have to be candles, but then this wouldn't work. So we cannot have this be 3. It's 1 or 2 here. Which means it must be with a 1 or 2 in one of these two spots. How does that work? Can you have 1, 1, and 1? Maybe. Huh. What happens if it's there? Can you have a 1 there? Then that's, and that being 2. So this is 2, 4 minus the neighbors having candle, so this is not candle. This cannot be candle in that case, which means this would have to be shaded. That would be shaded. And I don't think that works. because this has two neighbors which don't have candles. This has, well, this would have to be 1 and 1 to add up to 2. Therefore, this has 3 neighbors which don't have candles, so that would be shaded this way. This would have to be shaded that way. That would be shaded that way. I guess that's possible. Then you have 1 there. This would be 1. That would be shaded. This would have to be 4 ones. And the problem is this can't be 1. Right? So 4 minus 3 neighbors with candles could add up to 1. But 4 minus 2 neighbors without candles, with candles at most, is 2. Yeah, so this cannot be 1 there because of that. Can it be 2 here? So if that's 2, this is 1. No, because if this is 2, then this has to be 1. These have to be blue. But then this has 2 neighbors which don't have candles. So its height should be 4 minus 2. So it just cannot go this way. So this must go this way. This is blue. So this must be 2 here. So this is 2, this is 1. That means this has to be blue to form a region, a consecutive candle region. Therefore, this has 3 neighbors with candles. So this is candle, and this must be 1 here. So this is 1 and 1 there. Which means this has 3, this has to be blue, this has to be blue. So this has to be green here. So this must be 1. Because it has 3 neighbors with candles. 4 minus 3 is then 1. This has 3 neighbors with candles, so that's 1. This is 2 or 3 here. This has 2 neighbors with candles, so it's 1 or 2 there. And therefore this must be 2 here, which means we have 2 neighbors with candles and 2 neighbors without. So then this must be blue, this is blue there. So this must go green that way. This cannot be 4 because it would have a neighbor with a candle. So it's at most 3, so this cannot be boundary. This has to be, this is either 1, 2, or 3. So we have to have a 4 here. So this must be here, and that's 4, which makes that no candle. This is 2. This is 2, so this is not 8. You have to have 2... You have to have 3 cells at least with candles to add up to 8, because you can't have 4. So these are guaranteed to be green. This is 4. This could be 2 greens. If there's a 4, it cannot be here. It would have to be here. If it's not 4, obviously it's both of these. So this is green either way. So this is 2, 3, or 4 here. This is 3. So that adds up to 7 now. This We don't have any information there. 2, 3, or 4. We could have 3 blank 3 there. That is possible. Hmm. This has to be 1, 2, or 3 also, obviously. This is 1, 2, or 3. We have 1, 2, 3 there. Okay. Hmm. If this were a 2, that means it has to have blue there because it can't add up with another connected candle to add up to 2. So therefore this would be green, green, because its height must be 4 minus the number of neighbors with candles. So if we have a green here and it's 2, that would force this to be blue here, and this would have to be green, green. But that would mean the rest of these are 1. So this would have to be 1, 1, 1. And this already has a neighbor, which is without a candle. So the rest of the cells must have neighbors with candles. And then this would be too large. So this cannot be 2 if this is green. If this is green and 1, that could potentially work. That means all of these have neighbors. Actually, that also doesn't work. So we have 1, 1, and 1. Oh, it could be the middle set, actually. So that actually could work. If it's the middle set. Which it likely would be in that sense. So never mind. That actually could work. Hmm. Can you have this be 2 digits here is kind of a question, right? If you have 2 digits here, or 2 digits here, actually any 2 digits in this column, the problem with that is it has to be 1 and 2 as a pair, right? You could potentially have 3 1s here also. So let's try to see if that works. 1 means this has to be green, green and green. Because 4 minus number of neighbors containing candles, so that's 3 neighbors containing candles. This has to have green and green. And You could not have this be green here. That would force blue there. So this would have to be 2 and 2 in that case. 2 means 2 of its neighbors have candles. So this would be neighbor there. That would be neighbor there. That seems okay. This would have to be green here. That would be fine. Oh, that's interesting. For each of the sets of 2 and 1 here. So for each of the sets of 2 here, if there's a 2 by itself, that means you have to have blue be on either side, which means the neighbors with candles have to be here, right? If you have 1 and 1, so you can either have 2 by itself or 1 and 1 adding up, that would guarantee this must be blue. You'd have to have 1 and 1 here, and you would guarantee these have to be green, right? Because they must have 3 neighbors with candles. So for no matter what, one of these twos must correspond with a set of 3 here. One of these twos must correspond with a set of 3 here. And it could be as 2 or as a 3. Sorry, as 2 or 2 ones. How would that work? That means there must be a corresponding, so there has to be, so wherever the 2's are here, there must be a corresponding 1's in, there must be a corresponding, actually I guess it could have 3 digits here. If you have a 3 here as a separate one, it cannot go to here, essentially, is what we're saying. Unless this is 2. I guess that's possible. Can this be 4 digits here? That is actually a good question. If this is 4 digits, this has 2 neighbors that have candles, so this is 2 at most. This would be 2 at most, 2 at most. This could be 3 here, so this would be 1 and 2. So this would have to be 2 or 3. Seems like it's possible. Can it? Okay. Other things. What happens if this is green? If this is green, this must be part of the 5 that's at the end, because you can't have a single digit adding up to 5. You can't go blue there, so this must add up to 5 here. This has 2 neighbors with candles, so this is at most 1 or 2. This would be at most 1 or 2, same thing. So we have to have another one here. Hmm. This obviously can't be 3 anymore. It'd be 1 or 2. Hmm. So one of these would have to be a 1 because you have to extend it either here or both of them could be 1. Or you could extend it here and here. Uh, hmm. What happens if we have green this way? So this is the end. We have blue there. So we're trying to have just 3 there. Actually, we're trying to make this a 3, I guess, would be the point. So therefore, you'd have 3 neighbors, 4 minus 1 neighbor with a candle. So these are non-neighbors. Therefore, this is not 3. This would have to be 2 and 3. But that's not possible. So this cannot be the end here. Right? The only way you can have this being 3 here is if this is 3, 2, 3. And this is already two neighbors with candles. So this can't be 3. So this is filled guaranteed then. So this is always filled. Which means this cannot be 3 here. So that's 1 or 2. This is 1, 2, or 3. What happens if we make this a 3? So can we have 3, 2, and 3 there? 3 neighbors without candles. Neighbors with candles is 1. Neighbor with candles is 2. Neighbors with candles is 1. Therefore, this must go this way. We'd have 2, 1, 1. So 3 and 3 at the end. Which means the remaining digits in the middle must add up to at least 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore, it would have to be something like this. Okay, so if this is the case, this is a 3. This would have to be 2 greens here to add up to 5. So we'd have to have 2 and 3 here. No 3 here. 1 or 2. 1 or 2. This is 1, 2, or 3. So you cannot have 1 here. Or 1 here. Well, it can't be 1 anyways. This is 2 or 3. Because it has 2 neighbors without candles, which means at most 2 neighbors with candles. This can't be 1 either. If this is 1, 2, 2, 2, 1, 1, 2, 3, that's 5. 2, 4, 6, 8, and plus 1 is 9. That's 14, which is too small. So you'd have to be 2, 3 there. This would have to be 6. So this would have to be part of the one that adds up to 6. So this cannot have 3 neighbors. So this would be 2 and 3 there with candles. Therefore, this would have to be 3. So then this would be blue. This would have to be all green. This has 1 neighbor that has candles. No, 2 neighbors with candles. So then this must be 2. This must be 2 neighbors with candles too. So then this would be green. So this would have one neighbor with candles, so that would be 3. So far this is looking okay. This is 1 or 2. We don't know. This is 5. We have 3. So this is looking fine. We have 1 degree of freedom here. This necessarily must continue here in one of these. So this would have to be a 1. So therefore this would be 1, 3, 2, 2, 2 to add up to 15 in that case. Right? 2, 4, 6, 8, 12 plus 15. So this has 1 neighbor with a candle. So this must be blue and blue. This has 3 neighbors with candles. 2 neighbors with candles, so these are blue. This is blue, this is blue. We need to have another candle here, so that's green. This cannot be green, it must be blue. So this is 1. This must be either 2 or 3. Can this be 2? If this is 2, that forces this to be 1, and therefore that doesn't work. Because this would have to have 3 neighbors with candles, which it only has 2 at most. So then this would have to be 3. So this is blue. 2 neighbors with candles, this is blue. Okay. So far this is looking fine. This is at most 3, but it's 2 or 3. That means it must add up to 5, so this must be green there. And this must be either 2. If this is 2, this is 2. If this is 3, this is 1. Or it could be 2, 1, 1 potentially. This is actually looking okay though. Hmm. What about the other path? What happens? So we have guaranteed these 3 cells are in this consecutive span. What happens if we have 4? This then is what at most? It has to be 2 at most. Right, so this is 1 or 2. This can't be 3 anymore. So we have 2, 2, 2 at most there, which means this has to be at least 2. This can't be 3 anymore. So this is 1 or 2. That means at minimum, if we try to have these 8 have filled candles, that would be 3 and 2. I guess it could work. So if this is blue, this would be blue. Then you'd have 2, 2, 2. This would have to be 2, 2, and 3 to add up to 15. 5. This is 2, 4, 6, 8, 10. These would have to all be blue. And then we'd have a contradiction. because we don't have a first group here anymore, right? This must have one neighbor with a candle. These must have two neighbors with candles. Yeah, and that's a contradiction. So if we do that, that means this must be green. And if this is green, this has to be the one that's adding up to 5 because we can't have a 2 set adding up to 5 here. This cannot be 3, so it's 1 or 2 there. Which means we would need another one in one of these spots. Maybe what we should do is just see what happens if we extend all the way down here. So let's extend that. That means this can no longer be 3 because 2 of its neighbors are shaded. This would have to be 1 because 2 of its neighbors are shaded. This would have to be all 4 of these are shaded then. So this would be 1. So we'd have 1, 1. This, okay, so this cannot go down this way. Because this has 3 neighbors with candles, so it's 1. This has 3 neighbors with candles, it's 1. This has 2 neighbors with candles, it's 2. This has 2 neighbors with candles, it's at most 2. And that does not add up to 8. So we know this cannot be shaded, or candle, cannot have a candle. So it must not have a candle there. What about this? What happens if we do that? Then this must be 1. This is 2 at most, and it has to go shaded that way also. Therefore, this has 3 neighbors with candles, it's 1. This has 2 neighbors with candles. This could still be 3, though. So this could be... So it would have to... This would be 2 at most. That's 3. But that's 7, which is too small. So this cannot have a cell with a candle. So we are guaranteed then... if we have 3... So 2, 2. 3, 2, 2 is 7. 3, 2, 2. 1, 1. That's 9. 2 is 11 plus 2. And so these are green. So this cannot be 3. It's 1 or 2 here. This could be 1, 2, or 3 there. This has to be part of a 5 then. So this can never be 3 here. Can we have 3, 2, 2? So that would be 9 and then 2, 2, 2. That is possible. So this is guaranteed to be part of the 5 set here. So it can't, so therefore it has to be part of there. So one of these at least has a candle, which means this has 2 neighbors with candles, so it's at most 2. We just did this shaded, and that seems like it works. Does it though? I don't know. 3, 2, 3 seems like it worked okay. Oh, if we have this shaded, so this can never be 3 here. So I think that guarantees this has to be shaded then, right? Because if this is how can we have all of these add up if it's just these? So let's say this is, sorry, no candle. I keep saying shaded because that I'm I have blue here and green. But if we have candle here, what would this add up to? This would have to have one of these. So this would be at most 2, 2, 2, 2, 2, and this has 2 neighbors with candles at least, so this is at most 2. That's 6, 12, 14, which is too small. So even with this being shaded, this has to be shaded here. So this is shaded here. Then this could be 1, 2, or 3. One of these two. Okay, so this has to be 1. So this is guaranteed to be 1. It's going to have one of these be shaded. Therefore, if it's not shaded, if it doesn't have a candle here, this has to be 3, 2, 2, 2, 1, and 3. So that's 6. These 3 is 9, 11, 4, 13, 15. But this could be shaded also. Huh. So what happens if this is shaded? Then this can no longer be 3. So this at most adds up to 2, 2, and 3, which is 7. So therefore this would have to be shaded. This then has to be 1. This is unshaded here. This would be at most 2, so it's 1 or 2. And this therefore would have to be 2, 1, 2, and 3. So either way, this is 3, right? If this is unshaded, well, this could still be shaded. Okay, let's try this out first. 2, 2, 3. So this has 2 neighbors that are shaded or have candles. Therefore, the rest are unshaded. This has 1. This has 2. So then this is blue, blue. This has 2 neighbors, at least. So this has to be 1, 1 here, because it has to continue on here to add up to 5. This then is 2, 1, or 3. This has 3 neighbors with candles, so this is 1. So 1, 1, 1, 2, 3, 4, 5, plus 3, 2, 2, 2 at most is 9. And therefore this cannot be shaded, or it can't have a candle. So this cannot have a candle. And this is 3 at most. This must be then 3, 3, 2, 2, 2. So that would be 6 plus, yeah, to add up to 15. So then this is 3. That's 2, 2, 2. This is 3. That means this has to be shade. No candle, no candle. This is no candle. These have no candles here. No candle here. No candle here. No candle here. This has to be 3 here. That's 3. This is 2. That's 3, which means this has to have no candles in 3 of its neighbors. This is no candle here. Therefore, we have the 5 here. So this is green, green. This must be 2, 3 as a pair because neither of them can be 4. This has neighbors without candles, so this cannot be 1. So that's the reason why I went down a different path to try to disprove it, because I noticed that this actually looked like it was a solution. So we have 5 here. This must be part of the cell that's adding up to 6 because we don't have 2 available here to add up to 6 by itself. So this must have a neighbor with a candle here, at least. So it cannot be 3. It must be 2, which makes that 3. So this is blue. This has a singleton here. It's not 2. So this cannot have any other digits in this, any other candles in this row. Therefore, it must go down this way. This is not going to add up to 6 by these 2. So it must be having another candle here. This has 2 neighbors with candles, so this must be 2. Therefore, this must have 2 neighbors with candles to add up to 6. So that's 2. So then this must have a neighbor with a candle, and that's 3 there. Not 3, that's, yeah, 3. 1 neighbor with a candle, so that's 3. This is 2 or 3. If we try to have this as 2, then this would have to be here as a 1, but that 1 would signify it has 3 neighbors with candles, and that's not possible. So therefore, this must be 3 here. That means it has only 1 neighbor with candles. So no candle there. 3, 3. This is done 15. We need 1 more candle here. So this cannot have a candle because we need to have 1 space in an edge surrounding the cell without a candle. So this is 1. This must be 2 or 3. It has to be 2 because it must go to here because this doesn't add up to 5 yet. So this has 2 neighbors with candle. 4 minus 2 then is 2. So this must be 1 or 2 here. Okay, we don't have a candle here because this has to be a 5. This is 6, that's fine. This, we don't know. If this were 1, then you would have to have a candle here, and it would have to be 1. So only one of its neighbors could have a candle. Sorry, only one of its neighbors does not have a candle. But the problem is one of these has to be a neighbor without a candle because it must be 1 and 1, which would mean that cannot be blue. It would have to be green, and then this would be too large. So this cannot be 1 here. Then this must be 2. So this is 2, which means this is blue. So it's done as a region there. We have to have one of these be green. We're not sure which. Because to add up to 2 as a candle, we need 1 more digit. If we have a green here, the problem with that is it would have 3 neighbors. It would have only 1 neighbor with a candle, so it would have to be size 3. And that's not possible because it must be 2. So therefore, this has 2 neighbors with candles, so this must be 2. Don't have any other information here. This could be something there as a 3. Hmm. This is one of the question marks. We have 6 here. You could have 3 and 3. So we don't have any guaranteed candle cells here. Don't know about this. Okay, so this is done. This is done. This, not quite done, but we have the 6th part. 7 and 4 are done here. This is whatever. We have 4 and 4. Can... We have to have 9 here. So we could have digit here. 3, 2, 3 is possible this way. What is this? One interesting thing is here. If you can't have, you could have 1, 1 here potentially. 1, 1, 1. You cannot have 1, 1 here. Because if this is 1, so if this is green, this necessarily, if this is 1 of these is necessarily blue, which means it would not have 3 cells with candles in it. So therefore, if this is shaded, then so 1, 1 could be here, or you could have 2, 2, 2, and 2. Those are all possible. What about here? So if this is green, that would necessarily have to be 2. Oh, that doesn't work. Because it's at least 2. And this has to be 2 in this column to fulfill the sums. But the problem is this would have to be blue. And therefore that would force this to be 3, which is too big. So this cannot be green here. It must be blue. So we have 1 guaranteed, well, we don't have guaranteed blue there. We need a set of 3 somewhere here, at least. Because we can't fill in all here. So we have to have one of these be 3. Or 2, 1 pair. Or 1, 1, 1. Can this be 1, 1, 1 anymore? I don't think so, right? If we have 1, 1, 1 here... Yeah, this can't even be 1. So if we have green here, it's at most 2. Sorry, at least 2. And at most 3. But then this would have to be green here. So this would have to have... It could not be 3 anymore. Because one of its neighbors... Well... It could be 3. 2 and 3, 2 and 3, if that's the case. Say this was 3 and that's 2. So this would be 3 neighbors without candles. This would be blue. So one of these would be green, which is possible. Yeah, that works. Can this be green? I guess it could be 3 and these are all blue. Can this be green? Okay, so if this is green, that's 2. Well, it could be 1 and 1 tech. It can't be 1. This is that. Okay, so if either of these are green, it's 2, definitely. So we'd have to have 2 there. These would, and that doesn't work. So this can never be 2 either. And you can't have 1 and 1 here because both of these have less than 3 neighbors with candles. This has 2 neighbors without candles. This has, well, at most 2 neighbors with candles. So this can't be green. If we tried green here, this is at least 2. Therefore, this would have to be blue here. And we have 3 neighbors without candles. So this cannot be green. It's blue. What about if this is green? We have 1 neighbor with candles, so this would be 3, which means this cannot be. So this is blue. So we know one of these has to be at least, so this has to be green and is 2, which means it has 2 neighbors with candles. So it must be these 2. This or now has 2 neighbors with candles, so this can't be neighbor with candle. If this were 2, if this were green, the problem is it would have to be, if it's 2, it has to be at least 2, which means it's 2 here, which means it would have a neighbor. It would have to have 3 neighbors without candles, which means it would have to be 3 here. So this cannot be blue for the same reasoning we had there. So this is green. This must be a 2, and it must have 2 neighbors with candles. So that's 1, and this is 1. This now has 3 neighbors, 1 neighbor with candles, so this is 3. This has 2 neighbors with candles, so that's 2. This has 1 neighbor with candle at least, and it's going to be 1, 2, or 3 here. This has to be at least 2, so this is 2 or 3 there. We have to have 8 as a set either here, or we can try to have it here. So what happens if we have it here? So then this would be 3 greens. This would be blue. It would have to be 3, 2, 3, which would mean this is blue. This would have to be blue because it has to have 2 neighbors only without, and then this would be blue, but this doesn't add up to 6 then anymore. So this cannot be the one, so therefore this must be the one that's adding up to 8. Therefore, it has to continue on here. So this is green, this has to be green, which makes these all blue. This has no neighbors with candles, so this is 4. This has 2 neighbors with candles at least, so this is 1 or 2, which means it must go down here. And it cannot continue here because then that's too many cells. So this cannot be green because that would be 4 cells trying to add up to 3. So this is blue, this is 3 then. This has 2 neighbors at least without. This must add up to 6, so it has to go this way. This has 2 neighbors with candles. So it must be 4 minus 2, which is 2. This has 3 neighbors with candles, so that's 1. This has to go this way because this cannot be 4. So this has 3 neighbors with candles, so this is 1, which makes that blue. This has at least 2 neighbors with candles, but it has to go that way because it's not going to add up with 2 to add up to 8. So this has 3 neighbors with candles, so this must be 1. This has 2 neighbors with candles, so it could be 2 or 1 here. This cannot be 3 because it has 2 neighbors with candles. So then this must continue on here. So this has 3 neighbors with candles, so this is 1, which makes that blue. This is 1 or 2. This must be 1 or 2. If it's 1, you could have 1 there. So this must be part of the 6. So we have 3 here, 3 here, 3 here. This is definitely blue because we have green, green at most there. So this is blue. If we try to have green, green here, that would make these both 1. But then this would have to have 3 neighbors that have candles, and this doesn't have a candle. So this cannot be 1. This must be 2. So this is blue. So we have 1 neighbor with candle. One of these has to be a neighbor with candle. It cannot be this one, because if this is the neighbor without candle, this is only going to be 2, and 2 adding up to 6. So this has to go this way, which means these are the neighbors with candles. This cannot. So this adds up 2, 2, 4, 6, and 8. This does have 2 neighbors with candles, so that satisfies that. This has, it has to continue on to here, because otherwise it's 2, it can't be 4 here. So it's 2 and 3 at most, which would add up to 5. So then this has to be 1, 1, and 2. This is blue, so this must be green here. This is 1, so one of these is green, one of these is blue. This has to have 2 neighbors with candles, so this must be 2 here. So this must have 2 neighbors with candles, so this must be blue, which makes this green to have the neighbors there. This has 1 neighbor with candles, so this is 3. This has 1 neighbor with candles, so that's 3. So this must add up to 9. We can go at most 2, 2, and 2 there, so this is green. Or 2, 2, 2, and 3. This has to be 2 because it has 2 neighbors adding up. This is 1 or 2. This could be 1, 2, or 3 here. And it cannot be 3 because this has to be at most 2, so this must continue on here. So that's green. So these cannot be green because if they were, this would be too large of a region because it can only add up to 2. This has 1 neighbor adding up with the candle, so this is 3. This must go this way. You could potentially have all 1s, but the problem is this cannot be. This can't be 1. It has 2 unshaded. It has 2 neighbors without candles, so it would have to be at least 2. So this is not in a region. We have to have a 4. Okay, so this has to be, this has 2 cells with neighbors, so it's 1 or 2. This can this be 1 and 1? I guess. Then that would make, okay, so then these, so this has one neighbor without a candle, so that would be neighbor. This would then be what? This would have 2 neighbors with candles, so that's 2. 3 neighbors with candles, so that's 1. This is at least 2 neighbors with candles, so it'd be 1 or 2, which means I'd have to continue on there. This has at least 2 neighbors with candles, so this would be 6 here. So it'd have to continue on there. We need a 4 here. So this would be 4. These would have to be neighbors without candles. So this would have 1 neighbor with a candle, so that would be 3. And that would not work. So you cannot have this being 1, 1, is essentially what it seems like. Because this, you have to have a 4 here. So this has to be 2, which means this is blue here. Can you actually ever go here is kind of the question, right? Well, can you ever have this? Can this be a 4 by itself is another question. So you'd have blues all around here. If this were green, it would have to be 3, so this cannot be green this way. So then this has 2 neighbors. So this would be blue, this would have to be 2, this would have to be 1, and then we'd have this have to be green because it has to have 3 neighbors with candles. But then we'd have too many cells for the Japanese sum. So this cannot be 4 here. That means this is part of a 4 this way. So this must be green here. Because we're trying to have this be essentially the question mark, and then 4 here. But this is part of the 4 now, because you can't have 2 digits, because this is contiguous cells. This is sharing cells with 2 other cells with candles, so it's at most 2, which means it's 4 at most here, which means it has to go to there. If this were green, then I think these all have to be 1, supposedly, right? 1, 1, 1, and then we have a problem because this must have 3 neighbors with candles. So then this would have to be candle, and that would be too large. So this cannot be with candle here. This is blue. This has 2 neighbors with candles, so this is 2, which makes this 1 here. That means this has to be candle because it has to have 3 neighbors with candles. This has 1 neighbor with candle, so that's 3. These are blue. This has 3 neighbors with candles, so that's 1. So this has to have, this could be 1, 2, or 3 here. This must, okay, so this is done. 8, 8, question mark, 6 and 5. We don't have any requirements here. We have 4, 4, and 4. Question mark for 7. No requirements here. 2 and question mark. This we're still working on. 5, question mark, 5. Question mark 9. We have 6 question mark, and we're trying to get the 4. No requirements, no requirements. 3, 3, 3, and we don't have this yet. We have 2, 2, and 2. No requirements, question mark, 8. 3, 4, 5, 3, 4, 6, 8, 9, 10, 12, 15. Add up to 15. No requirements. Question mark and 6. Okay. So we need to finish this off. Can this ever be 1? Well, can this ever be green? If this is green, that means it's at least 2, which is too big. So this can't be green. Therefore, this is blue, and this must be 2 here. So that means 2 of its neighbors must have candle. So this cannot be 3 anymore. This is 1 or 2. And therefore, it must continue on here. So then this has to be 1 because it has 3 neighbors with candles. This must be 2. So it must have 2 neighbors with candles. So that's candle, candle. This has... So this is all done. It's 5. Now we just have to do the 3 here. So this must not be with candle because can't have all 4 neighbors with candles. So this is 1. This has 2 neighbors with candle. It could have 3, so it's 1 or 2. If this is green, it would have to be 3 at most, but then this would be green. This would be blue. So this cannot be green. It has to be blue here, which forces this to be green, and it must be 3, which makes this 1 with a candle. So that has 2 neighbors with candles, so that's 2, which makes this 1. And that's a solution. So we have 4, that's the one we needed to finish, and 3 here, and 5, and those are all done. So with candles, this has 2 neighbors with candles, so 4 minus 2 is 2. 3 neighbors, 4 minus 1 is 1. So 4 minus 3 is 1. 3 neighbors, 4 minus 3 is 1. So 3 neighbors, 2 neighbors, 2 neighbors, 1 neighbor, 0 neighbors, 2 neighbors, 3 neighbors, 3 neighbors here, 2 neighbors there, 2 neighbors here, 2 neighbors here, 3 neighbors here, 1 neighbor here, that's 4 minus 1 is 3, 3 neighbors here, 2 neighbors here, 3 neighbors here, 1 neighbor here, 1 neighbor here, 2 neighbors here, 1 neighbor here, 2 neighbors here, 2 neighbors here, 2 neighbors here, no neighbors here, 3 neighbors here, 1 neighbor here, 2 neighbors here, no neighbors here, 2 neighbors here, 3 neighbors here, 3 neighbors here, 2 neighbors here, 3 neighbors here, 3 neighbors here, 1 neighbor here, 1 neighbor here, 3 neighbors here, 3 neighbors here, 2 neighbors here, 2 neighbors here, 2 neighbors here, 1 neighbor here, 2 neighbors here, 3 neighbors here, 2 neighbors here, 1 neighbor here, 1 neighbor here, 2 neighbors here, 3 neighbors here, 3 neighbors here, 2 neighbors here, 2 neighbors here, 2 neighbors here, 3 neighbors here, 2 neighbors here, 1 neighbor here, 1 neighbor here, 1 neighbor here, and 2 neighbors here. And that's the solution. Yeah, hard seems about right. I was kind of curious how this would work because I've never seen this type of candle puzzle before. It's interesting the interactions that you have between them. And the Japanese sum definitely helps you out in limiting certain aspects. But yeah, I'm kind of curious about if there are potential other candle puzzles, which kind of could work. I'm wondering if you have to have a Japanese sum with it, though. Maybe. I don't know how much you can do with other types of clues. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.